Okay, so since we have a few questions here all for the same problem, I'm just going to list all the possible rational roots. And then I'll see A through E which ones match. So P can be 1, 3, 5, or 15. And Q can be 1, 2, or 4. So 5 over 1, so yes, this is a rational root. Could be a rational root. Negative 1 over 4, yes, that could be. The 3 over 2 could be. Here's the 3 over 2. 4 over 1 cannot. There is no 4 in the numerator. And there's no 3 in the denominator, so E cannot be as well. So again, all the factors of P here are 1, 2, and 4. All the factors of Q are 1 and 5. So to list all the possible rational zeros, I have to use all of the P factors over all of the Q. So 1 over 1, 2 over 1, 4 over 1, 1 over 5, 2 over 5, and 4 over 5. A fourth degree polynomial with real coefficients can have how many imaginary roots? Well, 4 could be the most. It could have 2 or it could have none. Because the degree is 4 for 68, there is 4 zeros. And how many are real? Well, for this I can use my calculator. And I'm going to look at the graph and see how many zeros or x-intercepts I can see. I can see 2, so there are 2 real zeros. So that means there has to be 2 imaginary because there's 4 total. Okay, again the same thing. Because the degree is 5, there's 5 zeros. To figure out how many are real, I'm going to look at the graph. I could also solve it and find all of the zeros, but because this is a calculator problem, there's no calculator symbol, I'm going to use my calculator. And there is 1 real zero. Okay, so to solve the inequality, I first need to factor and find all the zeros. I'm going to use my calculator. And if I can see 4 zeros in my calculator, then I know I have all of them. Here's all 4. 1, 2, 3. So I have negative 4, negative 1, 3, and 7. So if I write 70 in factored form, list my zeros. I'm going to put all my factors over here on the right. I'm sorry, the left. I know at all of these points there's a 0. So for each factor, I'm going to say, okay, a number less than -4, let's pretend and say -5. I could pick any number less than -4. And when I plug that into each factor, am I going to get a positive or negative? This would be negative, 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 and negative. So when I multiply all 4 negatives together, that gives me a positive factor, or a positive answer total. So if I pick something between -4 and -1, positive, negative, negative, and negative. So when I multiply these together, this gets me a negative result. 2 negatives are a positive. A negative times a positive is negative. I'm going to choose 0 here. So this is going to be positive. This together would be positive. 2 positives is a positive. And then 3 to 7. So positive, 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 and still negative. These will be positive, these will be negative, a negative answer. And then something greater than 7. Positive, positive, positive. So all 4 positives are a positive. And I want to know when the whole graph is positive. So that happens when x is when x is less than or equal, because we started with an or equal, -4. When x is between 3 and -1, here. And when x is greater than or equal to 7. Now I could have also used my calculator to find all of that. If I look and find the pieces of my graph that are greater than 0, they should all be in this interval. Okay, so since 71 is non-calculator, they give me the graph. I can use that to write the factored form. And I can also use the picture to look and see when is the whole graph less than 0. That's here and here. So that happens when x is less than, no equals in this one, -3, and when x is between 5 and 1. Okay, so for part A, since it gives me all of the zeros, again I can write that in factored form. And then it says solve the inequality algebraically. So that's what we're going to do again with the chart. And we want less than or equal to 0. So I'm going to list all of my zeros, all of my factors. And I'm going to choose numbers, let's say -7, -2, 0, and 9. -7 into this factor is a negative number, negative number, negative number. -2 into this factor would be a positive, a negative, and a negative. When I plug 0 in, and when I plug 9 in, So when we multiply three negatives, our answer is going to be a negative. We multiply a positive times a negative, that's negative. Negative times negative is positive. Here we're going to have a positive times a negative, and all positives. So we want less than or equal to 0. So that happens here. So that's when x is less than or equal to negative 6. And here, with this negative, when x is less than or equal to 8, but greater than or equal to negative 1. Okay, we're going to do the same thing. So all my zeros, all my factors, a number less, a number in between. Plugging in negative 5, I get a negative, and a negative. I plug in 0. I plug in 4 and 8. So we want, two negatives times a negative is another negative. This will be positive, this will be negative, and this will be positive. So when we're greater than or equal to 0, that happens between 3 and negative 4, and also when x is greater than 7. Okay, we're going to do the same thing again for number 74. Now we can use the calculator for this one, but I'm going to stick with the chart. Okay, so a number less than 0, in between. Oh, it would help if I put my factors in order. Okay, let's try that again. Negative 3, negative 1, 1, and 7. Negative, 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 positive, positive, negative, positive, and all of these will be positive. This gives me a negative result, this gives me a positive result, a negative result, and a positive. So the intervals where x is greater than 0 is between 0 and negative 2, and when x is greater than 6.